All right. So I just want to inform everybody that this session is recorded. So if you miss something important here in my session today, you can actually check it out this one in our completed section. All right. So today I will be discussing about binomial theorem. All right. So yesterday we have talked about the mathematical induction, right? The concept of that, and also the steps for proving such formulas. Okay, so let me know if you have questions or clarifications for mathematical induction before we proceed to our new topic, which is all about binomial theorem. Okay, so if you don't have no questions or clarification, please allow me to introduce the topic that we have, which is all about binomial theorem. All right. So all right. So why do we need to study about binomial theorem? So I'll give you some insight. So the reason behind is that it helps us to have a quick way, all right, of expanding a binomial expression that has been raised to some power. Say for example, especially for the bigger numbers. Say for example, you have the highest exponent or the bigger exponent. For instance, take a look out of this. Say for example, we have your x plus 2 raised to 10, all right? So using binomial theorem, we can actually easily solve that one, okay? For not using the FOIL method, because we know that this one is actually equivalent to x plus 2 times x plus 2 and so on and so forth up to 10, isn't it? So using the binomial theorem, we can actually use that, okay? So before we proceed on this, let's recall the binomial. So we all know that binomial is a polynomial that has two terms, all right? So in this section, we will study a formula that will give us an easier and quick method of raising a binomial to a power. So to start with, look at the expansion of a plus b raised to n here. Okay, so for several values of n. So say for example that your n, which is your exponent, has 0 value. Okay, and we all know that any number that is raised by 0, we all know that is actually equal to 1. And if you have here 1, okay, a real numbers for value of n, okay, say for example you have here n as equal to 1, we all know that this is actually equivalent to a plus b, isn't it? In simplifying or in expanding that, okay? While in a plus b raised to 2, okay, we have your binomial, okay, we have two terms and it is raised by 2, and we all know that if you're going to simplify this one, you will come up with this trinomial, which is what we call the perfect, right? The perfect trinomial, isn't it? So this will be the concept, right? And so on and so forth. Okay, so for if your exponent is equal to 3, then therefore, in expanding this binomial, you will be having a raised to 3 plus 3a squared b plus 3a times b squared plus b cubed. All right, so that will be the concept. So if you're going to no, if you're going to observe that one, notice in the expansion that there are n plus 1, right? So say for example that if I'm going to add plus 1 here, say for example 0 plus 1, you will be having 1. 1 plus 1, you will be having 2. Okay, so this is something like there's a counting number, right? So notice in the expansion that there are n plus 1 terms, so the power of a, as you can see here, the power of a decrease by 1 naman in successive terms, okay? Whereas the power of b increase by 1 naman, okay? So opposite with variable a, right? So again, as you can see here, take a look out of this. For example, for instance, we have here a plus b raised to 3. As you can see here for a, um, the um, the the power or the exponent is decreasing, right? We have here 3, we have here 2, we have here 1, right? There's a automatically 1 here, invisible 1 here. So it is decreasing, right? While on the other hand, we have here also your b, okay? Your b is what? Increasing naman po. As you can see here, we have here actually an invisible b raised to 0. We all know that b raised to 0 is actually equal to 1, isn't it? That's why we don't need to to write b raised to 0. So 0, let's start from 0, 0, 1, 2, 3. Okay, so do you see the concept? Okay, so the sum of each power, as you can see here, the sum of the sum of each power of A and B, okay, so the power will be 2 and 1, will actually equal to the n that you have, which is equal to 3, as for always. Okay, for instance, take a look out of this. We have here 1, we have here 2. So 1 plus 2, if you're going to get the sum of that, you will be having 3. Also for this, right? Automatic 3. And 2 plus 1, you have here 3. So all in all, if you have the if you're pertaining to the exponent that you have, so if you're going to get the sum of your um, two terms in binomial, okay, you will come up with the value of your n. Okay, and also the coefficient increase, right? The coefficient increase and decrease in a symmetric pattern. Okay, so the coefficient of a binomial expansion are what we call the binomial coefficients. Okay, so to find them, we can make use the binomial formula itself. Okay, so take a look out of this. So this will be the concept. So there is a more handy way to bear in mind the pattern for binomial coefficients. Okay, yung kanina po in our previous slide. So by arranging the coefficients in a triangular pattern, it will show the following array, okay, as you can see here, which is called the Pascal triangle. So that will be the concept of Pascal triangle. Okay, so when we say triangle, this one, as you can see here, it's a triangular array, right? It's a triangular array, as you can see here, of the binomial coefficients. Okay, so this is actually this triangle, this concept is named after the French mathematician Blaise Pascal. Okay, so based to him, we can actually, we can um, actually easily memorize the pattern for binomial coefficient using this Pascal triangle. So as you can see here, we have your n equals 0. We all know in the previous slide that n equals 0, wherein your exponent is 0, we will be having 1, right? And for n equals 1, for the numerical, numerical or the binomial coefficients, you will be having 1 and 1. As you can see here, we have your 1 and 1, right? So if your n equals 2, then we will be having three terms, right? Wherein your first term is actually equal to 1 and your middle term is actually equal to 2. Okay? Regardless of the terms binomial that you have, which are the a and b, right? So we have here also the last term that you have. So as you can see here, we have here the pattern. So we have here um, all ones, okay, for this one. So if you're going to have one here, so let's just only copy one and one, so one. So you just need to get the sum of this for you to have the middle term for your n equals 10, 2 rather, okay? For instance, here, okay, so how do we come up with 3 and 3? So you just need to add. So copy 1 and 1. So we assume that your first term and your last term is actually equal to 1, okay, regardless of the binomial po. And your how to get your 3, you just need to add 1 plus 2, you will be having 3, and 2 plus 1, you will be having 3 also, okay? And so on and so forth up to the end. Okay, for instance, take a look out of this. So we have your 1 and 3, you will be having 4. 3 plus 3, you will be having 6. 3 plus 4. 3 plus 1, you will be having 4. Okay, so that's the concept of Pascal's triangle. Okay, so in addition, you can actually write the binomial coefficients using the combination concept. Are you familiar with combination? So if you see something like there's a NCR in your calculator, okay, that will be read as the number of combinations of n objects taken r at a time, okay, as you can see here. So this will be um, the um, the representation, for instance. So the combination will be like this. So it can be represented as the number of combination, okay, the number of combination of n objects, okay po, of n objects taken are at a time. Do you see it in your calculator? Do you see it? Let me know. Okay, so you can actually use this, okay? For instance, so we have here your R. Your R is actually the number of items being chosen at a time, and your N will be the number of items you have. For instance, say for example, we have your N equals 6. So your N will be sold as your 6, okay? Will be 6, as you can see here, and your R will be served as the number of terms you have. Okay, for instance, we have your first term, second term, third term, fourth term. Okay, so this will be served as the R you have. For instance, we have here the combination of six, okay, taken six at a time. So if you're going to, if you're going to simplify this one, you will be having one, okay? You can actually represent this one. So later we will know the concept or the use of this combination. Why do we need to add this one in this concept, okay? All right, did you get it? For instance, this one, okay? So we have here the combination of six taken five at a time, okay, and so on and so forth. Okay, so this will be your n, this will be your exponent. Okay, let's say that will be served as your exponent, and your r will be the number of items being chosen at a time. Okay, so this will be the six, the five, the four, three, two, one, and the zero. Okay, since we're talking about the first and the last. Okay, did you get it? So that's the concept. So, in connection with that, through with that concept, we will formulate here the formula. Okay, the formula. So, binomial theorem. Suppose n is any positive integer, then the expression a plus b raised to n is given by this. Okay. So, if you have here this equation or this binomial theorem, you can actually rewrite this one as this. Okay, for a simple computation. For instance, so this is actually equal to, so this is actually, reads as n choose 0, okay? Or it can be the combination of n objects taken 0 at a time, this one, times a raised to n times b raised to 0 plus n choose 1 times a raised to n minus 1. As you can see, this formula is the um, concept of this one, right? So nagma-minus po. So dito nag-minus 1 po tayo, right? Kaya naging 2 siya. So that will be the concept of this. That's why we need to subtract n minus 1 and so on and so forth. Okay? That is continuous for as long as, if, for example, your n is actually equal to 1 million. Okay? It can be also 100 and so on and so forth. So you can actually use that. Okay? For expanding such binomial. Okay? So where r plus 1 term is actually equal to this one. Okay? This is actually equal to this. So the combination, the formula for combination, you can actually use this one, okay? But then you can actually direct input the data here in your calculator po. But in manual calculation, you can actually use this formula. So n factorial all over n minus r, quantity n minus r factorial times r factorial, wherein your r, the number of items being chosen at a time, okay, is greater than or equal to 0 but less than n. Okay, so your n, it can be your any number of that. Okay, wherein your n should not be equal to negative integers. Okay, so in short, your R should always a positive, okay, a positive integers, okay. In summation notation also, you can actually represent that one into summation notation, this formula. So it can be like this, okay. So the summation of the number of combination of n objects taken R at a time, okay, times a raised to n minus r times b raised to r from r equals 0 up to n. Okay, so that will be the formula. That's how you read that one. Okay, so for you to understand more, let's have an example for you to understand more. Okay, so example one, use the binomial expansion formula to expand. For instance, we have here this problem. Okay, so actually this is small, ano pa eh, maliit pa, right? Because your exponent is 5. So you can actually use something like ax plus 3, right? quantity 8x plus 3 up to 5, right? But this is time consuming pa rin, okay? So we can actually use the formula itself. So using the formula, okay, as you can see here, we have your 5. So your n will be what? Will be equal to 5. And your r is a counting, okay? It's a counting number as you can see here. Okay? So mag-add lang po tayo ng 1. Okay? As you can see here, let's start from 0. So we have your 0, 1, 2, 3 up to 5, okay? And your n, as per always, your n is equal to 5, okay? So we have this combination. So f choose 0, as you can see here, okay? And as you can see here, to solve this one, I want you to, to have generalization for this. So you have to write first the first and the second term, okay? So you have to multiply. So let us write muna. So we have your 8x, we have here 3, okay? So we have your 8x and 3, multiply lang po. You have your 8x up to the sixth term, okay? Up to this one. So you have to write. And what's next? Okay, as you can see here, diba, as what I said, your first term, the exponent of your first term, dapat po ay decreasing. And your second term should be what? Opposite po, decreasing. So let's start from 5 kasi ayun po ang highest natin. So let's start from 5. You will be having here 5, your first term, 5, 4, 3 exponent, okay, 2, and 1. So that's the concept. What about the second term? Okay, so let us start from 0. So increasing naman siya up to 5. Okay, so you will be having here 0, 1, okay, imaginary, 2, 3, 4, and 5. Do you see it? Do you see the concept? Okay. So once you are now done, you can now actually simplify that one. And that's it. Okay, that will be now the answer if you're going to expand ax plus 3 raised to 5. For instance, I want you to type the combination in your calculator, your NCR there, if you see that in your calculator. Okay, so the combination of 5 objects taken 0 at a time is actually equal to 1. Okay, let me know kung 1 po ang lumabas sa ating calculator. Okay, and for your 5, choose 1, okay? So if you're going to simplify this one, or it can be written as 5, it can be written as the combination of 5 taken one at a time. It could be like this in your calculator, okay? So you will be having 5 as the result, okay? So that's calculator matters, okay? And also here, you can actually use the formula itself as what I stated in the previous slide, okay? And this one, if you're going to simplify 5, choose 2, you will be having 10, okay? And so on and so forth, okay? 5, choose 3, the answer will be 10. 5, choose 4, the answer will be 5. And 5, choose 5, the answer will be 1. Okay, then let us simplify. What is 8 times 8 times 8 times 8 times 8? We have here 5. Okay, the answer will be 32,768. Then we have your x raised to 5 because we have your automatically 1. So you have to multiply exponent to exponent. Okay, so you will be having here x raised to 5. And since this is raised to 0, automatically that is equal to 1. So we don't need to put 1 here. Okay, and what's next? Simplify this one. 8 raised to 4, that is actually equal to 4,096 x raised to 4. Okay, then times 3, copy only. Okay, so you can actually direct na po. Direct is simplify. So 3 times 4,096 times 5, then you will be having this one. Okay, you will be having this one. So there's a x raised to 4 here, ha? Don't forget. Okay, so 5 times 4,096 times 3, you will be having 61,440 x raised to 4. Don't forget x raised to 4, okay? As you can see here. So there's x raised to 4 here. What's next? Okay, what's next? Simplify this one. So 9. How do we come up with 9? Because 3 squared is 9. And 8 times 8 times 8 is actually equal to 512x cubed. And then simplify this. Multiply all. So 10 times 512 times 9. Then you will be having 46,080 times x raised to 3 for this. What's next? This one. So multiply only. So how do we come up with 27? You just need to simplify 3 raised to 3. You will be having 27. And for your 8x, okay, we have your square. So you just need to square that one. So you will be having 8 square, that is 64, then x squared. Then 10 times 64 times 27, then you will be having 17,280 x squared. And do the same thing here, okay? You will be having 3,240x and 1 times 243, then you will be having 243. Since 3 raised to 5 is 243, and this is raised by 0, that is automatically 1. And this one, 5 choose 5 is actually equal to 1 also, so 1 times this 243, then the answer will be, for the constant, will be 243. Okay? Did you get the concept? I hope you get the concept for this. Okay. All right. So I think that will be the example for expanding this binomial. Okay, this one. So I hope this is only for today, and I hope you learned something new. Thank you for listening.